In order to help change toxic gases that cars produce into non-toxic gases, a catalytic converter is used. This catalytic converter gets its name because it uses a catalyst to help in the reaction to convert the toxic gas into a non-toxic form. A catalyst is a compound used to help a reaction occur faster by lowering the activation energy. There are two types of catalysts, homogeneous and heterogeneous. A homogeneous catalyst is a catalyst that is in the same phase as the reactants, while a heterogeneous catalyst is a catalyst in a different phase than the reactants. As we just covered, a heterogeneous catalyst is in a different phase than the reactants. Because of this, it can't mix in with the reactants. The most common way these catalysts work is that the reactants adsorb onto the surface of the active site of the catalyst. With the reactants connected to the catalyst, the reaction occurs faster. There are several different mechanisms by which this occurs. Sometimes the reactants are brought into close proximity with each other. Sometimes the connection between one of the reactants and the catalyst helps make the reactant more reactive. After the reaction occurs, the catalyst releases the product. A good catalyst needs to bind tightly enough to the reactant to allow the reaction to occur, but weak enough to release the product. Let's take a closer look at some examples of heterogeneous catalysts. There are several processes which use heterogeneous catalysts to help speed up the reaction. The contact process is one of the most widely used methods for sulfuric acid, H2SO4, production. By adding excess oxygen to sulfur dioxide, sulfuric acid can be formed, but this is a very slow reaction. Vanadium dioxide, V2O5, is a brown-yellow solid on which the oxygen and sulfur dioxide can adsorb in order to react with each other to form sulfuric acid. This reaction is interesting because the vanadium oxide is reduced during the process of this reaction. Simply adding extra oxygen reforms the catalyst so that it can still be used. Methanol, CH3OH, can be produced by many different methods, but by using carbon monoxide and hydrogen, a lot of energy in the form of heat is also produced, which can be used as power. The carbon monoxide and hydrogen method isn't as fast as other methods, such as keeping a stream of carbon dioxide, water, carbon monoxide, and hydrogen gases mixed together to form methanol. So a catalyst, such as chromium oxide, Cr2O3, can be used to make this an energy-efficient method. Ammonia, NH3, is an important product used in commercial farming. One way it can be made is through the Haber process, which uses nitrogen and hydrogen to form ammonia. In this process, nitrogen from the air can be used, a plentiful reactant. Iron is used as the catalyst, but it isn't pure iron. Instead, iron and potassium hydroxide work together to help the nitrogen and hydrogen come together to combine into ammonia. As we mentioned earlier in this video, a homogeneous catalyst, the catalyst and the reactants are in the same phase. This allows the catalyst to directly interact with the reactants. Sometimes the catalyst can be positively charged and bring two negative charges together. An example of a homogeneous catalyst is oxidizing iodide ions with peroxide disulfate ions. Iodine can easily be oxidized, and the peroxide disulfate ion can easily act as an oxidizing agent. The problem is that peroxide disulfate ions and iodide ions both have a negative charge, so they are repelled by each other. Putting iron 2 or iron 3 in with the solution allows the reaction to occur quickly. The iron has 2 or 3 positive charges, so it can attract both a peroxide disulfate ion and an iodide ion into close enough proximity so that the peroxide disulfate ion can be reduced and the iodide ion oxidized. A subset of a homogeneous catalyst is autocatalysis. Autocatalysis is when the catalyst is part of one of the reactants. When oxalate, C2O4, reacts with oxalic acid, a slow reaction occurs where carbon dioxide is formed. But if manganese is added, it speeds up the reaction substantially. The manganese can be added as MnO4, replacing the oxalic acid. In this case, the manganese is part of the reactant, so autocatalysis is occurring. Catalysts are great for speeding up a reaction, but if the catalyst isn't pure, it won't work properly. An impure catalyst is known as a poisoned catalyst. The impurity makes it less efficient because the catalyst will interact with the impurities instead of the reactants, using up active sites on the catalyst. Poisoned catalysts can be very costly for a manufacturer. If the catalyst isn't as efficient as it could be, then the manufacturer can't produce as much of their product. The contact process to make sulfuric acid historically used platinum as the catalyst, but platinum is often poisoned with arsenic, making it a lot less efficient. So now, vanadium oxide is typically used. In the Haber process, methane is often used to manufacture the hydrogen gas. However, methane is often mixed with sulfur. The sulfur can interact with the iron catalyst, making it less efficient. Thus, the methane must be cleaned prior to use. Have you ever noticed how your gasoline says unleaded? There's a specific reason why the gasoline needs to be unleaded. The lead in gasoline is a catalytic poison. It forms a thin coating over the catalyst, making it unable to react with the fumes to detoxify them. Let's take a few moments to review what we've learned in this lesson about the different types of catalysts in chemistry. Essentially, a catalyst is a compound used to help a reaction occur faster by lowering the activation energy. These catalysts can be homogeneous, which means a catalyst that's in the same phase, or heterogeneous, which means a catalyst in different phases. A homogeneous catalyst mixes the catalyst with the reactants, allowing it to speed up the reaction. One type of homogeneous catalyst, an autocatalyst, is part of one of the reactants. A heterogeneous catalyst generally has the reaction occurring on the surface of the catalyst, at the phase between the reactants and catalysts. Catalysts can become impure or poisoned, making them less efficient, which is costly for companies trying to manufacture specific compounds.